This video explained the centroid of the rectangular T-beams that will help to finding the deflection in the reinforced concrete beam. Now the cross section of rectangular T-beam is shown here, which has a top flange and which we have a bottom web. Now in these calculations we are going to first divide these composite shapes into the top rectangle and bottom rectangle, that we are going to reference it here. So the area of the top rectangle would be 1000 millimeters times 120 millimeters, that's give me 120,000 millimeters square. The centroid of the top rectangle is measured from the reference line which is at the bottom. The centroid measuring from here is 680 plus 60 millimeters, which is half of 120, give me 740 millimeters. That is the distance from the centroid of the top rectangle from the bottom reference. Now area of this second rectangle is 680 millimeter by 300 millimeters, give me 204,000 millimeters square. Now the centroid of the second rectangle from the bottom reference is just half of 680, which is 340 millimeters. Now the equation to calculate the centroid of the rectangular RC T-beams is the area of the top rectangle times the centroidal distance from the reference line plus area of the second rectangle times the centroid the distance from the bottom reference divided by area of the top rectangle plus area of the bottom rectangles. Now I substitute the value. Area of the top rectangle is 120,000 times the distance centroid would be 740 millimeters plus area of the second rectangles, which is 204,000 millimeters square, times the centroidal distance is 340, which is y2, divided by the area of the top rectangles that are substituting from here plus area of the second rectangle 204,000. The simplifications gives these two numbers ratio, and if you simplify this using the calculators, give me 488 millimeters. Now 488 millimeters measured from the bottom reference somewhere between the two centroid. Now that's quick check makes sense that this centroid of this composite shape, centroid of the whole cross sections is sitting between two individual centroid. Now that's give us the verification of this value partially correct, which is 488 millimeters. Now this calculation help to calculate the moment of inertia that we will explain it in the next video. Thank you.